Hi, this is Geetika Somisetti, and our project name is Named Entity Recognition in Social Media Text. So, the statement of this project objectives is to develop a named entity recognition system specifically designed to extract entities from social media text. And named entities can include names of people, organization, location, dates, numerical expressions, and more. So, by developing an effective NER system for social media text is crucial for various downstream NLP tasks. So, by accurately identifying named entities, we can unlock valuable insights from the vast amount of unstructured data generated on social media platform. Statement of value. Why is this project worth doing? So, accurate name entity recognition in social media text is crucial for extracting valuable insights from user generated content as well as in exchanging various applications such as sentiment analysis, trend analysis, and personalized recommendation. So by improving NER performance contribute better understanding and utilization of user generated content and also more effective on decision making and communication strategies. Review of the state of art and relevant works. So recent advancement in NER techniques have addressed several challenges and opened up new opportunities for application in social media context. And there are some key research paper provide insight into challenges and opportunities for NER in social media approach. So here we utilize deep learning architectures such as BILSTM CRF, and BART for NER task and leveraging pre-trained languages model. After that, we pre-processing social media text using techniques like tokenization, normalization, and spell correction to handle informal language and misspellings. And then we explore transforming learning techniques to adapt models to unique characteristics of social media text. And then we fine tune by using fine tuning on annotate social media data sets. Deliverables. First, we trained NER model optimized for social media text. Pre-process, script, and data techniques to handle informal language and abbreviations. And then documentation, detailing model architecture, training processes, and usage instructions. Evaluation methodology. The methodology for named entity recognition in social media text involves data collection from various social media platforms, reprocessing to clean and normalize the text data, development of deep learning models for NER. So utilize state-of-the-art deep learning architectures such as bidirectional, LSTMS, and transform-based models or CNN. Train the model on the data set for entity recognition, and then fine tune the model for social media text characteristics. After that, evaluation of model performance using standard metrics, and then deployment of the NER model for real time entity extraction. And this is the evaluation of methodology. Thank you.
Hi, I'm Anwar Rashid Sheikh, and I'll take you through the code and the deployment. So let us dive into the code implementation. We'll start by importing the necessary libraries and modules. Here, we're importing the libraries and modules required for our named entity recognition model. We're using the PyTorch library for deep learning along with the Hugging Face Transformers library to leverage pre-trained BERT models. Next, we'll load our named entity recognition datasets from a CSV file. Here, we are loading our dataset from a CSV file using pandas function. Let's take a quick look at the first few rows of our dataset. And then moving on, let's pre-process our dataset for training. We'll handle missing values, tokenize the text data, prepare input tensors, and split the data into training and testing sets. Here, we are pre-processing our dataset tokenization, the text using the BERT tokenizer, and splitting it into a training and testing sets. We've also defined a label dictionary to map the named entity tags to numerical formats. We train our model using a by LSTM CRF architecture. We'll iterate over multiple epochs, optimizing our model's parameters to minimize the loss function. We're training over um, 10 epochs with a batch size of 32. As you can see, the loss decreases gradually with each epoch, indicating that our model is learning to predict the named entities more accurately. In the second model, we import all the required libraries as in the first model. The difference between the first model and the second model is we don't have a CFR layer in the second model, and the rest is the same. We train and split data. So the coming to the output of this model, here we've trained our by LSTM model over 10 epochs with a batch size of 32. As you can see, the loss decreasing gradually with each epoch, indicating that our model is learning to predict named entities more accurately. Now, we use a pre-trained BERT model for token classification. Here we are loading a pre-trained BERT model for token classification and demonstrating how to use it with an example input text. The model outputs prediction for each token in the input text. Output is this output consists of logits for each token in the input text. These logits represent the model's confidence scores for each token belonging to one of the classification labels. In a real world scenario, these logits would be further processed to obtain the final predicted labels for each token. Then here's a refined version of the token classification demonstration using the pre-trained BERT model. In this version, we've structured the code into functions for better modularity and readability. We load the pre-trained tokenizer and model tokenize the input text, perform prediction using the model, and print the output. This approach helps us allows for a easier reuse of the code and makes it more maintainable. The logits represent the raw output of the model before applying any normalization or activation function. They provide insight into the model's confidence score for each token belonging to the different labels. Thank you.
Okay.